Welcome, my dear students. Let's explain a new lesson in chapter 4. Our new lesson today is distribution property. So what is the meaning of distribution? Distribute means divide. We studied it before in the division lesson. Distribute. Okay. Do you remember how to decompose the number? Decomposing the number means divide the number into two parts, like this. Number like number 6. How can you decompose this number? 6, it's equal 1 plus 5 or 2 plus 4 or 3 plus 3. That's the meaning of decompose the number. Let's decompose another number. Number like number 8. How can you decompose this number? Like 1 plus 7 or 2 plus 6 or what? 3 plus 5 or 4 plus 4. Okay, that is the meaning of decomposing the number. Here in this array we have long side like this and short side. How many squares in the long side? Let's count together how many squares in the long side. 1, 2, 3, 4, 5, and 6. Okay, in the short side we have 1, 2, 3, 4. Can you represent this array? So we can represent this array as excellent. It's 6 times 4. Let's go back to our lesson. Our lesson is distributive or distribution property. So we will distribute or decompose the big number. The big number is 6 or 4. Excellent, it's 6. So we will decompose the number 6, and the small number 4, it's never a change. We will decompose, as we said before, number 6 into 1 plus 5 or 2 plus 4 or 3 plus 3, and never change the small number 4. This array, we will never change the small number 4, and we break apart this array into two parts. 6, we will decompose number 6 in this exercise into 3 plus 3. The first part of array, we represent it as 4. In the short side, it's never changed, and the first part is 3. The first part is 3. Can you read this array or represent this array? Yes, this array is represent as it's 4 times 3. This array is represent as 4 times 3. The second part of array is 4 in the short side and 3 in the other side, like this. 4, it's never changed, and 3 as we decompose. Can you represent the second part of array? Yes, we can represent it as 4 in the short side and 3. How can you get the area of this array? The area of this array, we will get the first part as 4 times 3 and the second part 4 times 3, and adding these parts together. The first part 4 times 3. 4 times 3, it's equal what? Excellent, it's equal 12. Second part 4 times 3 also. Okay, 4 times 3 is equal 12. So now we add 12 plus 12. 12 plus 12 is equal 24. Excellent. Okay, we will take another exercise in the same array. Array which represent as 6 times 4. The small number 4 is never changed, and we will decompose number 6 into another two number like this. We will decompose number 6 into 4 plus 2. This array is 6 in the long side and 4 in the short side. we will decompose 6 into 4 and 2. 4 in the first part and 2 in the second part, like this. 1, 2, 3, 4, it's never changed. The first part of array is 1, 2, 3, 4. As we decompose number 6, can you represent this first part of array? Yes, it's represent as 4 times 4. Excellent. Second part of array, can you represent the second part of array? Yes, it's 1, 2, 3, 4. 4 by what? It's 4 by 1, 2. 2 the second part of array. Okay, to get the area of this array, we will adding the first part plus second part. The first part is 4 plus 4. 4 plus 4 is equal 16. The second part, 4 times 2. 4 times 2 is equal 8. So we will adding 16 plus 8. Don't forget 4 here and here, it's never a change. 16 plus 8, it's equal 24. Okay, let's take another exercise in the same array that represent as 6 times 4. We will decompose number 6 with another two number. We will decompose number 6 into 5 plus 1. So this array, the short part, 1, 2, 3, 4, it's never changed, and the long part, we decompose it into 5 and 1, like this. The first part of array is 1, 2, 3, 4, it's never changed, and 1, 2, 3, 4, 5. Can you represent this array? Yes, it's 4 times 5. Okay, the second part of array is it's 1, 2, 3, 4. Don't forget, it's never changed. 4 times what? 4 times 1. To get the area of this array, we adding the first part with this color and the second part with blue color. The first part, 5 times 5. Sorry, 4 times 5. 4 times 5 is equal, excellent, it's equal 20. Plus 4 times 1. 4 times 1 is equal, excellent, it's equal 4. Now we adding 20 plus 4. 20 plus 4 it's equal, excellent, it's equal 24. Now we finish this exercise. Let's open our booklet, page 115, and solve this exercise together. In this array, here we have long side and short side. We decompose or distribute the long side or short side. Excellent. We decompose or distribute the long side. The long side represent 1, 2, 3, 4, 5. The long side, it's 5. So we will decompose 5 into two numbers. Okay. The short side, 1, 2, 3, 4. 4, it's never changed. So we will put number 4 and it's never changed. Okay, we can decompose number 5 into 4. 4 plus what? Okay, it's 4 plus 1. 4 plus 1, it's equal 5. We will put 4 in the first part and 1 in the second part. Okay. To get this array, we will finish the first part. This part is 4 times 4. 4 times 4 is equal what? Excellent, it's equal 16. Second part, 4 times 2. 4 times 2 is equal what? It's equal 4. Then we will adding 16 plus 4. 16 plus 4 it's equal, excellent, it's equal 20. Let's solve another exercise. In this array, here we have the long side and here we have the short side. Don't forget, we distribute or decompose the long side or the short side. No, the long side. The long side here we have 1, 2, 3, 4, and 5. The short side 1, 2, 3. So 3, it's never a change. We will decompose the long side, which represent number 5. Okay, 3 and the short side, it's never a change. We will decompose the biggest number, number 5, into 4. 4 plus what to equal 5? 4 plus 1. So we will put in the first part here, we will put number 5, and second part here, we will put number 1. We will finish the first part. First part, 3 times 4. 3 times 4, it's equal, excellent, it's equal 12. Second part, 3 times 1. 3 times 1, it's equal, excellent, it's equal 3. Then we will adding 12 plus 3 together. 12 plus 3 is equal, excellent, it's equal 15. Let's take another exercise. In this array, which is the large side or the big side and the small side? Here we have the long side. The long side consists of what? 1, 2, 3, and 4. The short side 1, 2. So, well, number 2, it's never a change. We will decompose only number 4. Okay, number 4, it's equal 3. 3 plus what? 3 plus 1. You can do it as 2 plus 2. Okay, or 0 plus 4. In the first part, we will put 3. In the second part, we will put 1. 2 never change in the short part. Okay, of the small number. We will finish the first part and the second part and then adding these two numbers together. The first part, 2 times 3. 2 times 3, it's equal 6. Excellent. Second part is 2 times 1. 2 times 1, it's equal 2. Then we will add 6 plus 2. 6 plus 2, it's equal 8. Excellent. Let's solve another exercise. In this array, we have long side and short side. In the long side, here we have 1, 2, 3, 4, 5, and 6. Okay, in the short side, here we have 1, 2, 3. So we will decompose 6 or 3. Excellent. We will decompose the big number. We will decompose number 6 into two numbers, like 1 plus 5 or 2 plus 4 or 3 plus 3. 3 in the short side, we put it here, it's never a change. So we put 4. 4 plus 1 equals 6. Excellent, it's 4 plus 2. So we decompose number 6 into 4 plus 2. In the first part, we put 4. In the second part, we put 2. We finish the first part of array 3 times 4 and we finish the second part of array 3 times 2, then adding this number together. 3 times 4. 3 times 4, it's equal, excellent, it's equal 12. The second part of array 3 times 2. 3 times 2 is equal, excellent, it's equal 6. Then we will adding this number together. It's 12 plus 6. 12 plus 6 is equal 18. Excellent. This array, let's solve another exercise. This array, here we have the long side or short side. Excellent, it's the long side. The short side, it's never a change. So number 3, the small number, it's never a change. So we put here 3 and 3. We decompose the big number. Let's count how many circles in the long side. 1, 2, 3, 4, 5, 6, and 7. So we will decompose number 7 into two parts, like 1 plus 6, or 2 plus 5, or 3 plus 4, or 4 plus 3, and so on. So we will decompose number 7 into 4 plus what? Excellent, 4 plus 3. 3 never change. We will put number 4 here in the first part and number 3 here in the second part. 4 in the first part and 3 in the second part. We will finish the first part and we will finish the second part, then adding these two parts together. 3 times 4, 3 times 4, it's equal 12. Excellent. 3 times 3, it's equal, not 6, no, it's equal 9. It's times, yes. 12 plus 9, 12 plus 9, can you adding 12 plus 9? Yes, 12 plus 9, it's equal 21. Now you can solve on your booklet, page 117 by yourself and ask me for anything. Okay, thank you.